Hello students, welcome to IMS Gate Academy. But already I started operational amplifier in this session. There I have done number of problems. Still I would like to do few more number of the questions. You practice it. Yes, I can start problem from the operational amplifier. Different models from different papers I collected. Those I want to give here now. Yes, note down this question, you can understand. In the ideal op-amp, ideal operational amplifier. Ideal operational amplifier, circuit given in the below figure. The value of R suffix f is RF is varied from 1 kilo ohm to 100 kilo ohm. 1 kilo ohm to 100 kilo ohms. 100 kilo ohms. The gain G equal to the gain is given G equal to V naught by VI will be and 4 options are given. Those 4 options also I will give. You can understand clearly. Yes, good evening Nikhil. Good evening Manoj Kumar. The 4 options are given. I would like to give here now. Option A is given here. Remain constant at +1. Option B is given. Remain constant at -1. Option C is given. Vary as minus RF by 10,000. Vary as 1 plus RF. And here the network is given like this. There is an op-amp minus and plus. This is given with V naught, and here given with 10K resistor, and here given 10K. This is 10K. This is connected to VI, and here given RF variable. This is the given problem. This is RF. Yes. Can you do this question? Any student can do this question without my help? Is it possible to do this question? What is given in the problem? In the ideal operational amplifier circuit is given in the below figure. Yes, there is an op-amp. the value of RF is varied from 1 kilo ohm to 100 kilo ohms. There is a resistance RF here that is going to change. Yes, excellent question, sir. Okay. Yes, VA is given 10K, 10K. RF is changing from 1 kilo ohm to 100 kilo ohms here now. There is a change of value of this RF here given. Is asking gain V0 by VI. That ratio required V0 by VI. That will be this or this or this or this. We need to identify. But a gain depends upon, gain remains constant or variable, you can understand only when you get V0 by VI. The gain in terms of RF you got, we can say clearly, it depends upon the RF only. Otherwise, any variation we can see in the gain. I will do here, clearly you can understand. But I want to take solution here now. This network we can redraw, but I can draw like this now. This network I can draw in this way, minus and plus. There is a V0 here, and here connected with a 10K resistor, and also VI is common for the negative terminal and also for the positive terminal. I connected what now this VI I would like to separate. For the negative terminal 10K and VI is given. For positive terminal 10K and VI is given. Just I want to bend this. 10K is given here, and also VI is common for both. There is an RF. There is an RF. I would like to draw that. That is a variable. Its value changes, it is given here now. It is a very simple question. Anybody can do this. But you know very well, this node voltage is, what voltage possible here now? What node voltage we can get here now? We cannot find any current across 10K. What is the reason? The input impedance of operational amplifier is very high because it is an ideal op amp, it is given clearly. Input impedance is very high for ideal op amp. In that case, what current is passing across 10K? 0 amperes of current is passing. It doesn't flow any current due to high resistance only, we can say. When there is no drop across 10K, at this node, I can have the same voltage VI. Same voltage VI I can have. But under virtually ground concept, you know, V plus and V minus are equal. Very first class, I derived that. V plus and V minus are equal. If it is a VI, even this node voltage is also same VI. It is also with VI only. Same VI, this also. But this side current is 0 only. It doesn't flow because I want to apply the nodal analysis to find the V0. This current plus this current equal to 0. Anyhow, this current is 0 only now. VI minus VI, 0 only possible. Current across 10K becomes 0 only. I can write VI minus V0, VI minus V0 by RF. RF equal to what? This current is 0 means even this current also 0 only now. Because this current is not passing here now. The same current must pass this side also. So when this current is 0, this current also 0 only possible. That equal to 0. So finally, I can get VI minus V0 equal to 0 only. So finally, V0 equal to VI, and the gain I can get directly. Gain is nothing but V0 by VI, that equal to how much? Plus 1 only possible. The gain I am not getting in terms of the RF. If I got in terms of the RF, any one of the options may be chance. But anyhow, the gain is 1, remains constant. That means even you are changing the value of RF from 1 kilo ohm to 100 kilo ohm, the gain doesn't change. It is going to remain constant only, we can say. That's why what constant is possible? It remains at plus 1, I can say. Option A is correct, we can say. This is the answer for this question. Followed? Shall I go to the next question? Any doubts, anybody? Any students are having any doubt regarding this problem? Yes, I will do next question now. The Manoj Kumar 1. Yes, exactly correct. Yes, same answer. +1 only now. So option A is correct. Very perfect. You are perfect, Mr. Manoj Kumar. And I want to give you one more question in your hand. You please try this now. You please try this. I wish to give one more question. Yes, I want to give one good problem. You please tackle this question. The following signal, question is somewhat big. It's a very good question. The following signal, VI of peak voltage 8 volts, it is given, is applied to non-inverting terminal. Of an ideal op amp, here given, ideal op amp. The transistor has VBE equal to 0.7 volts, 0.7 volts, beta equal to 100, beta is given 100. Voltage across LED, light emitting diode, LED is given. That voltage is given 1.5 volts. 1.5 volts. VCC is given 10 volts. VCC is given 10 volts. And minus VCC also given. That's given minus 10 volts. Minus 10 volts. And here given one circuit like this. There is one 8K resistor and also connected with a 10 volts, and here connected one 2K resistor. This is a 2K, and there is one op amp. This is a minus and plus. This positive terminal is connected to VI. Here it is given VCC equal to 10 volts minus VCC is nothing but minus 10 volts, it is given. 15K resistor is connected here. There is one transistor and connected to the LED here with a resistance of 100 ohms and connected with 10 volts. There is one LED here. Light emitting diode is connected here. This is given as a LED. This is connected to the ground. But when the input voltage is given here VI, there the output waveform also given, how the shape of the output will come, that also given here. This is T. That waveform is given here like this. It goes to top and goes to down. Such a way it is given, but it is exactly same only here possible. Stand same. And I will give clearly. The waveform is given like this. This output is available. The sudden voltages are given. This is VI, it is given here. This is given 6 volts here. 6 volts. And the next one is nothing but the 4 volts also given here. This is 4 volts. It is given. And also minus 2 volt, 2 voltage here given. This is 2 volts. And here given, this is minus 6 volts. And also 4 voltage is given here, minus 4. The waveform is given like this. Next one is nothing but minus 2 voltage here. The waveform, it came like this. That is the output waveform. But the question here is, what is asking the problem? The number of times the LED glows, is dash. Yes, options also given. I don't like to give the options here now. Can you identify how many times LED glows? Because of giving this waveform. The input waveform of the what now? This particular circuit is given. This is a VI. That VI is nothing but this. If it is given, how many times the LED glows? The input is given from 0. This is the 0 voltage here, no doubt. 0 to some voltage. Up to this extent only now. Up to that extent waveform is given. Anybody can do this question? How many times LED glows when this signal is given as an input? VI is given, that input only. Any chance? Anybody? Tell me, Manoj Kumar. Can you try now or shall I do? Do you have any idea? If there is no idea, I will do, no problem. Yes, I will do, please watch. I will do this question. It doesn't take more time. It's a very simple question only now. But I want to give the solution here now. But in this network, when LED glows, first you arise that question. When LED is going to glow? If transistor is on, then only LED glows. If transistor is off, no current passes, no collector current passes here now. At the time LED comes to off state only now. When transistor will be on? Next question. When transistor is on, when there is a base current here, if base current is passing here, then only it can glow. When base current will flow? If I have this base voltage, positive potential. But here it is given one operational amplifier. but here the minus VCC is nothing but minus 10 voltage. Here the plus VCC is nothing but the 10 voltage you got. Out of these two voltages, which voltage is required to operate the transistor? Is it a positive potential or negative potential? That is the first question. It must be base voltage must be positive potential is required. The positive potential whenever I am getting now, transistor will be on. It will be forward bias. Base to emitter will be forward bias. Current starts flowing. Then collector current will pass. And what is going to happen here now? And what is going to happen here now? Once the transistor is, once this voltage is a positive, base current will flow, collector current will flow, and LED glows only now. Yes, somebody is giving now. Harihara, I will act as a, it will act as a comparator. Yes, very good. Very good, very good. That is why what now, out of these two, here I want to get the positive potential only now. If I got the positive potential, then only on. When positive potential I can get, first of all you need to check, this is the V minus value. V minus is this potential. V plus must be this potential one. If Vi, it can act as a comparator, exactly correct now. If Vi is greater than this potential, then output will be plus VCC only possible. If this voltage V plus is greater than V minus, V naught must be plus VCC, already explained. If Vi is less than what now, this V minus, this output will be V minus 10 voltage only possible here now. That is why initially we need to check what voltage at this node is possible. That is very, very important now. So initially I would like to find this voltage. This voltage I want to find. When 10 voltage, if you connected current is going to pass across 8K and 2K, what current will pass in this direction? The same current will pass in this direction. It will not divert any current this side because the high resistance I said already now. So when the same current is passing through the what now, these particular two branches, we can say this voltage, we can apply voltage divider formula. V minus I can get here now. So V minus equal to, I can write according to voltage divider formula, 10 into 2K by 8 plus 2, 10K, 10 I can write. Finally, I am getting the 2 voltage only. 10 into 2 by 8 plus 2, 10. I am getting the 2 voltage. Now try to catch my point. If Vi is greater than what now V minus means 2 voltage, transistor is on. When Vi is greater than what now 2 voltage, I will get this voltage, base voltage. Now VB equal to 10 voltage possible. That's why I can write one sentence now. If Vi is greater than what voltage? V minus equal to what? 2 voltage. VB must be 10 voltage possible. If it is 10 voltage, transistor is on. Yes, Manoj Kumar gave 3 times on. Yes, we can check. We can check now. Yes, even Harihar Shudan also, but he also gave the what? Answer is what? 3 only gave it. No, I will check the now. I will check the now. Understand now. 10 voltage, then transistor is on. That means if the Vi is greater than 2 voltage, then on. Greater than 2 voltage means this is greater than 2 voltage. Yes, input I am getting this waveform. Transistor is on. Greater than 2 voltage. If Vi is greater than 2 voltage, then on. Greater than 2 voltage, on. If it is less than 2 voltage, you think it's so. What's going to happen? If it is less than 2 voltage, from here to here, the transistor is off. Between these 2 points, transistor is off. So LED will not glow. Again, when the input voltage is greater than 2 voltage, again it is on. This is totally greater than 2. Again transistor is on. But again when it goes to what now? Less than this. Less than 2 voltage means again it is off. From this point to this point, transistor is off. So we cannot find LED to glow here now. And again greater than 2 voltage. Greater than 2 voltage means I can put like this now. From this point to this point, greater than 2 voltage, transistor is on again, and it will not come to the on state when this input is given here now. Here off state only possible. Finally, on state, how many times it is going to glow LED? 1, 2, and 3. So we can write directly, we can write LED glows is 3 times only. 3 times is exactly correct. Yes, you are correct, Manoj, and also Harihara. Harihara, I will say now. Harihara also exactly done now. 2 students exactly done now. This is right. I think you followed only now. But I want to give you one more good question in your hand. You please try this question. Without my help, you please complete. I want to give one more good question. But your practice is more important now. When I give one question, immediately you start doing this question. If you are getting answer, immediately you send it now. I can check whether it is a correct or wrong. Yes, one more problem. How many students will do? I will see. Find V naught. Find V naught. Operational amplifier is ideal. Op amp is ideal. Find V naught. Operational amplifier ideal. When switch S is closed, switch S is closed only. When switch is closed, you need to calculate. There is a voltage source here, there is a operational amplifier here, and this is connected to the V naught, and here connected with one resistor R, and also connected with one battery here. But I hope you can do. Here one switch is connected here. This is closed at t equal to 0 seconds. There is one capacitor C. Yes is asking to find the V naught here now. Will you get answer? Anybody can give answer without my help? Without my help, you please complete. And this is connected to the ground. This is the given problem. I will see how many students can give answer. You please try. If you give answer, very good. Whether it is a correct or wrong, don't bother. You make an effort. If you got answer, very good. Otherwise, I will do. Please start doing. How we need to calculate V naught value. Yes, I will also do. Parallelly you do it. Parallelly you complete this question. Sorry, this voltage is not given, V only. This voltage is a V only. Yes, this supply voltage is given V only. This is V. Yes, I will do. Please watch. When switch T equal to 0, switch S is closed. Switch S is closed at T equal to 0. We know very well it is given ideal op amp. Op amp is ideal is given. So V plus and V minus must be same. 0 voltage means this is also same 0 voltage. We know when the switch S is closed, this current I means same current will pass this side. I and IF. IF means I only now. Here the voltage across the capacitor is more important here now, because this current equal to what now? V minus 0, I equal to this IF or something, current across capacitor, I equal to IC only possible, no doubt. First of all, voltage across the capacitor we need to calculate. Without computing that value, we can't do. Voltage across the capacitor, you know very well. 1 by C integral I dt. I means current across capacitor into dt. There is a formula from the networks. You can use 1 by C into IC into dt we can write now. But in the problem it is given, but directly integrate now. IC by C into what? Dt integration T. IC into T by C, we can say here now. So what is IC you get from the what given problem? You please try. What is IC here possible? You please try this. You find what IC is possible from the given problem. Anybody can try what is IC here? What IC is possible here? We know very well I equal to IC here. Same current will divert. What is I? V minus 0 by R. According to Ohm's law, I can write V minus 0 by R. The current across this is how much? Current across this I can write. But we can write for now IC equal to we know already ICT. This is equal to ICT by C I can write here now. ICV. Otherwise directly we can write anything now. Still we can write easy way only now. Still easy way we can write if you want. If you want you can write still easy way. Still easy way we can write the now. But IC by T is given here now. What is IC here? IC and I are same only now. I can write what I wish to say. What is IC means I and IC are same. I and IC are same. What is I? V minus 0 by R. I can write V by R directly. V by R I can write directly. I equal to V by R. I can write IC is nothing but V by RC into T I can write here now. Into T I can write. That is VC value. My aim is to find out the what now V naught only now. How we can find the V naught? V minus 0, this current equal to this current. V minus 0 by R, that means V by R equal to what? 0 minus V naught. 0 minus V naught. But otherwise what now? Voltage across the capacitor I can write Y. Voltage across the capacitor. Voltage across the capacitor is how much? What is voltage across the capacitor? Anybody can say? What is the voltage across the capacitor is possible? Those two currents are equal. Equate both currents, you will get answer. Already voltage we are getting here now. We are unnecessarily what now making the mistake here now. Directly possible. I am getting this now. 0 minus V naught equal to 0 minus V naught equal to voltage across the capacitor. Try to catch my point. Initially, I am calculating the voltage across the capacitor. Vc equal to 1 by C integral IC dt only. 1 by C into T, dt integration T, IC I have taken as T is. I would like to find what is IC. IC is nothing but what V by R because IC and I are same. Then I want to find the VC, what a V naught value, 0 minus V naught. 0 minus V naught equal to VC only possible. Yes, directly I will get answer. Minus V naught equal to VC. VC is nothing but VT by, yes, very simple question only. Unnecessary we made difficult. And V naught equal to I can write directly minus VT by RC I can write. Yes, that is answer. It's a very simple question. Answer is minus V by R. No. Minus VT by RC only. Minus VT by RC only. Minus VT by RC. Followed or not? Because V naught I can get 0 minus V naught equal to VC only. 0 minus V naught equal to VC only. That VC value we have to compute. That's why I calculated VC value. Wherever VC you got, directly you can substitute VT by RC only. VT by RC only. You are giving V by R means what is the meaning? Current across the R only you are giving here now. I am not asking the current. I am asking the V naught. So V naught equal to minus VT by RC only volumes. That way we can. Followed or not followed? Is it required any more explanation for this? Anybody? If anybody is in need of the explanation, I can give the no. If you followed, I can go to next question. Shall I go to next question? Followed or not followed? Yes, I would like to give the one more question of the same model. How many students can do this? I will see. I will give one more question of the same model I will give, you will understand clearly. Find VC. Is asking to find VC. Is asking to find VC. Voltage across capacitor is required. Voltage across capacitor is required at T equal to 1 millisecond. at 1 millisecond I want. Here the network is given. There is an op amp. Op amp is ideal. There is a common. I am not writing there now. 1K resistor is connected here. And here connected with plus 5 volts. It is connected with plus 5 voltage. This is connected to the ground. When the switch is connected, I want, when switch is connected at t equal to 0 seconds, you need to calculate t equal to 0, switch is closed. This is the capacitor. Its value is given 1 microfarads. Is not asking to find the V0 value. Is asking to find out the capacitor voltage only. But here don't do the work. Already we know very well voltage across the capacitor equal to how much we know for this type of model. That voltage across the capacitor formula, you take it directly, substitute the values, you will get answer. What formula is given here? What formula is given already? But I gave the formula. I gave you formula. Voltage across the capacitor equal to, already I gave it. What I gave it? Voltage across the capacitor Vt by Rc. Vt by Rc. That's given already. Those values directly you can substitute. Yes, you substitute and tell me what answer you can get. Just substitute and tell me. The V is nothing but the supply voltage 5 volts. The T is given here the 1 millisecond, 1 into 10 power minus 3. And R is given here 1K. And C is the capacitance of the capacitor 1 micro. Can I get answer for this question? What is Vc? You please tell me. What is Vc? You please tell me. What Vc you will get? Anybody? Anybody can give what is Vc value? 5, exactly correct. This voltage is nothing but a 5 voltage. The one more problem I want to give, same model question with a slight change I will give. But you try to use your brain and give answer for this. With a slight change, understand now. While doing the question, you can understand what change in this problem. Understand. The next question is, the next problem is given like this. Find V0, not asking Vc, V0 at t equal to 3 milliseconds. 3 milliseconds. And the network is given like this. There is an op amp. This is a V0 here. This is connected to the ground. Here given plus 10 volts. This is minus 10 volts. And 1K resistor is connected here. And the supply voltage is given with 5 volts. The switch is closed here at t equal to 0. Here given one capacitance of the capacitor here. This capacitor is given 1 microfarad only. 1 microfarad. Yes, you complete this question without my help. But I will see how many students can complete this question. How many students can give answer. I will see. But I will also do here now. You please try. At a time we can complete. But in this problem we know very well, this side of the circuit already I gave it. But here we need to calculate voltage across the capacitor. Without this voltage we can't get. What change in this problem you can understand. Voltage across the capacitor equal to, I gave V into T by RC. Just now I derived that formula. Vt by RC. The V is nothing but the 5 volts here. The T is nothing but how much? T equal to what? 3 milliseconds. And R is given 1K. And C is given 1 micro. Anybody can give Vc value here? What Vc you are getting? Please tell me. What Vc you are getting? Anybody? What VC you are getting? Please give me. Minus 15. Okay, answer how much VC, please tell me. What is VC? I am asking. What is the VC value? I am asking. 15 voltage. Minus 15 or VC equal to mostly what is possible? 10 power minus 3 here. Is it 10 power, what now? 10 power minus 6, 10 power minus 6 cancel. 5 3 is 15. Yes, 15 voltage is possible. We are getting the 15 voltage only. The 15 voltage you got means, is it possible to get that much voltage? VC is nothing but the 15 voltage. Okay, you can put no problem then. VC equal to 15 voltage. Then you measure what is what now? Output voltage. This voltage is 0 voltage. We know very well 0 minus V naught equal to what? Difference of this voltage equal to, we know very well, VC only. VC only. But a V naught equal to what is possible? Minus VC is possible here now. That is nothing but minus 15 voltage only. But I am asking the question now. But this circuit is in a position to give the minus 15 voltage or not? Can it give minus 15 voltage? But minus VSAT is nothing but the minus 10 voltage plus VSAT is given 10 voltage only. The output must be within this range only. Minus 10 to 10 only it can give. Here the minus 15 voltage is impossible. V naught is unable to give that much voltage because less than minus 10 voltage means it will try to truncate. It will try to truncate and it can give V naught equal to how much voltage? Only minus 10. That means V naught equal to minus 15 voltage is less than minus VSAT. Less than minus VSAT means V naught will be, V naught must be what? Minus VSAT only possible. Minus VSAT means what value possible? Minus 10 voltage only possible here. Now, it doesn't give minus 15 voltage. It can truncate the rest of value only. That is the answer for this question. Did you understand? Followed or not followed, other students? Please respond. If you got any doubt, you can arise. Yes, I would like to give one more problem with a slight change. I will not give same model, don't worry. I want to give with slight change one question. Yes, I want to give one more question now. The output voltage, of the following circuit, of the following circuit assuming ideal behavior, comma, is dash, and the given network is this. The network is given like this. There is an op amp, this is a minus and plus, and here this is connected to the 1K resistor here and also connected with 1 volt. There is one 2K resistor here, 2K resistor, this is connected to this point, and one more 4K resistor is connected here, and also one more, and also connected one more 8K resistor here. There is an op amp, this is V naught here, and this is connected to this point. The V plus is connected with 1 volt, and also one more 1K resistor is connected. V plus is connected to 1K resistor. I'll connect here now best. This is 1K resistor. This is 1K. This is connected to this point. Yes, that is connected to that point. but I want V naught value. I want no V naught value. But these are the operational amplifiers are what? Ideal behavior only now. They were all with ideal behavior. Can you get V naught from the given problem? Anybody can do this question to find V naught here? Initially you take this question and start doing this question. You please start doing this question. You start doing this question. But I want what is V naught here? What is V naught? I want. What is V naught? Yes, I will also do here now. Please watch here now. I will also do here now, but I want solution for this question. But you know very well this voltage is nothing but V naught. This voltage is V naught. Anybody can respond? What voltage can exist at this node point? What voltage can exist at this node point? Anybody? Anybody can respond? What voltage can exist at this node point? Any student can respond? What voltage can exist at the node point? The same voltage, V naught only now. If it is a V naught, same voltage will be maintained at this point. So I would like to take this voltage as a V naught only now. That voltage is a V naught only. Exactly correct. This a V naught means you know very well, even this node voltage is also same V naught. I can take this voltage as a V naught only now, because V plus and V minus are same only now. And one more point you have to remember, this voltage is a 1 voltage, this voltage also 1 voltage. So this node voltage also I can have 1 voltage only. Initially we need to understand what voltage can exist at this point. I wish to take it as a V1. Once I know this V1 value, by using this op amp I can find the V1 value. By using this node voltage I can find out the V naught value only. What I say, initially I wish to find the V naught, V1 in terms of V naught you will get now. You please watch. I wish to apply the nodal analysis here now. This current plus this current equal to 0. It doesn't flow any current this side. Input impedance is infinite, you know very well. What current passes in this direction? V naught minus 1. I can write V naught minus 1 divide by 1K plus this current is nothing but V naught minus V1, V naught minus V1 by 2K. These two current summation equal to 0 only possible. K cancel, cross multiply. 2 V naught here minus 2, 1 into plus V naught minus V1 equal to 0 I got. My aim is to find the V1 at first. V1 is required. V1 is required. Yes, V naught equal to 1. Exactly correct. Exactly correct. Harihara Sudan, exactly you are correct. 1 only now. Yes, I am getting 2 V naught plus V naught is nothing but the 3 V naught. That equal to how much? V1 plus 2 by 2 I will get now. 3 V naught equal to 2 plus V1 is possible. What is V naught? If I ask, anybody can say V1 plus 2 by 3 only possibles. Yes. Sorry, V1 I want, is it not? I am in need of V1 I say. I am in need of V1 only now. What is V1 here? Because my aim is to find the V1 only now. V1 equal to I can write 3 V naught minus 2 I can get now. That is V1 value. Once you got the V1 you can get now. Again nodal I will apply. This current plus this current equal to 0. 1 minus V1. 1 minus V1 is 3 V naught minus 2 I can get here now by 4K. This current is 1 minus V naught plus 1 minus V naught divided by 8K, that equal to 0 only possibles. Yes, we are getting in terms of the V naught only. You try to simplify. And finally, you are going to get V naught equal to 1 voltage only. If you simplify, you will get V naught equal to 1 voltage. The process is only now. By using this node, by using this node, I wish to apply the nodal analysis, then I am getting the V1 only now. Again, by using this node, nodal is applied, V0 we calculated only. This is the methodology to find out the V0. Now, I would like to give one more question. Manoj Kumar 1 exactly correct. Yes, it's correct only now. I wish to give the one more good question in your hand. You please try this. But I want to give one more question. You try to practice. You give answer with your own efforts. The output voltage the output voltage V0 of the below circuit is dash, and here given problem like this. There is an op amp minus and plus. This is connected to the one voltage source plus minus. This is 1 millivolt. And here it is connected with a 10K resistor. This is connected to the ground. 100K resistor is connected here. 100K resistor is connected here. And also 47K resistor is connected here. 47K resistor is connected. And one more op amp connected here, minus and plus. This is connected to the ground. Here connected with 470K. 2.2K resistor is connected here. 2.2K resistor, and there is an op amp. This is a minus, this is a plus. This is connected to the ground. 22K here connected. This is 22K. This is V0. But I want V0 from the given problem. Can you try this question without my help? You please try. If you are getting answer, very good. If you face any problem, I am here to help you. Please start doing this question. 10K and 100K and 47K and 470K, 2.2K, exactly correct, 22K. Yes, you start doing this question. What is V0? What is V0 is very important. You please start doing this question. Anybody? Yes, I will also do here now. You please watch. If it is a 1 millivolt, this voltage is also same 1 millivolt, no doubt. But it is ideal op amp only, not given. In the bracket you write ideal op amp. Op amps are ideal. Initially, I would like to find this voltage, V1. What network it is? It is a non-ideal operational amplifier. It is a non-inverting operational amplifier. This is non-inverting operational amplifier. From the non-inverting operational amplifier, you know very well, V1 equal to what? 1 plus R2 by R1 times of this voltage only. This voltage we can assume V1, Vx or something. Vx into Vx I can write. I can write 1 plus R2 is nothing but the 100K divided by R1 is nothing but 10K. Vx is nothing but 1 millivolt. And finally, what I can get? 10K is a 0, K cancel, 10 plus 1, 11 millivolts. I am getting 11 millivolts V1. By using this voltage, I can measure V2 value. This circuit is an inverting operational amplifier. This is non-inverting. This is an inverting operational amplifier. From the inverting operational amplifier, you know very well formula minus R2 by R1 minus 470K divided by 47K into this V1. V1 is nothing but 11 millivolts. 11 millivolts. Anybody can give what is V2 here? Anybody can give what is V2 here? What V2 here possible? The V2, it comes as a minus 110 millivolts. Minus 110 millivolts, it is possible. But again, by using this V2, I can measure what is V0. Again, it is a inverting operational amplifier. This is inverting operational amplifier again. From this inverting operational amplifier, I can get V0 equal to what? Minus 22K by 2.2K multiplied by this V2. V2 is nothing but minus 110 millivolts. Millivolts we are having. The use calculator, you will get V0. What V0 you are getting? 99 volts. No, check it once again. It comes as 1100 millivolts. It comes 22 by 2.2K minus 110 into 10 power minus 3. It comes as a 1100 millivolts here possible. That much voltage it comes. That answer is possible. Please check it. Can you check Hari Harshodan? Can you check answer? It comes as 1100 millivolts. Correct or not? Once again you check that. Getting same or not? Okay, sir. Very good, very good. Okay. And so far we have done the problems of this model now. But how to find out this? Sometimes in the GATE exam is asking to find out the input resistance. Input resistance through which path you will give clearly now. Direction will be given now. But I will start from the simple question. Slowly I can raise the what now? Level 1. 1100 millivolts. Manoj Kumar. Exactly correct. That's same only. 1100 millivolts. Very perfect. But to find the input resistance, I will do certain number of the problems. You will understand clearly now. To find the input resistance, I wish to give certain questions now. The starting problem will be somewhat easier. Slowly, I will make it complicated only now. Understand? The find R in input resistance, I want. Find R in. R in means input resistance I want. For the circuit given. For the circuit given. For the circuit given. And here given op amp like this, minus and plus. And this is the V0 here. The R1 is connected here. This is connected to the ground. And this is connected to the what? V in. This is given as a V in. And is asking to measure that resistance only. R in equal to how much? When the view is made this side, what R in is possible? Here given RF. RF1. They were required what is R in? When the view is made this side, what R in I can get? Based upon the direction it is given, you can form a formula like this. Input resistance equal to, you know very well, input voltage by input current only. Input voltage by input current. So I say it's a very simple question, starting problem. R in equal to what? Input voltage is nothing but V in. The current which passes this side is, how much current will pass across V plus? it doesn't flow any current. The reason is what? Input impedance is very high and current is approximately equal to what? 0 amperes only possible. This current I will take it as a I, for example. So V in by I is nothing but the R in only. In this part, V in by I want. V in by I is nothing but the 0. Something by 0, infinite. So infinite resistance at the input side we can find. The starting problem very simple. Infinite resistance is possible. You can understand when I did number of questions, you will get idea. Next question, with a slight change I will go slowly. I will try to improve the level. Next question. But I want to give the next question here now. Find R in is asking to find R in. Find R in input resistance I want. For the given circuit, I can say, for the given circuit, here given one operational amplifier minus and plus, positive terminal is connected to the ground, here connected with R1 here, and also connected with one source V in or Vi, it is given. Here V0 is taken from here, here connected with RF. This is RF, I can put here now. The direction is shown like this, is asking to find R in this direction. I want R in, such a way it is given here now. Such a way it is given. Anybody can try this question without my help? Initial work is required on your side. Yes, I will also do. Just 2 or 3 problems I will do. You can understand. But input resistance equal to input voltage by input current I. This voltage by this current is R in only now. You know very well, V plus is 0 voltage, V minus must be 0 voltage, no doubt. Must be taken like this now. But I want R in. R in equal to what you can say, Vi by I. Vi by I can say. So what is by I equal to how much here? I wish to find what is I. I equal to everybody knows. Directly, that is the formula only now. I equal to what first of all? I is the current across R1. Vi minus 0 by R1. Vi minus 0 by R1 I can say. But I want V1, Vi by I. This is R in. That equal to how much it comes? R1 only possible. R in equal to R1 only now. R1 is nothing but the resistor only now. So R in equal to R1 only possible. That way we can get now. With a slight change, I will give one more question. You can understand clearly. The slight change I will give. With a slight change I will give. Find R in. Find R in. I am asking to find R in. Find R in for the circuit given below. For the circuit given below. Given below. How to find this? There is an op-amp minus and plus, here given with V0. Here the given with what now, a resistor R1 here connected with R2, and here given supply voltage Vi, and this side it is connected with R1. This is same R1 connected to the ground, R1 to the ground, and RF is connected here. Yes, can you get answer for this question? Can you try this? Manoj Kumar R1. Yes, correct. Last problem is R1 itself. Anybody can try this question without my help? And the direction is given this side. The direction is given like this. Find R in is asking here now. Will you get answer for this? What is R1? R in. I want R in from this problem. Please try this question without my help. How we can find here now? But we know very well the R in is nothing but VI by current which passes this side, VI by R, VI by voltage by current only now. That ratio I want. When the supply voltage is connected, current will start flowing this side. Is it passing any current across? But this side, the I will pass and same I will flow this side. It does not flow any current in this direction. No current will pass in this direction. This current is a 0 amperes only because input impedance is very high. It doesn't allow any current this side. Even it passes some current, there is a negligible only, we can take it now. Anyhow, the same current is passing this side. When the same current is passing here now, we can find what is R2 value here now. R2 equal to what I can get here now. Current equal to how I can get. It is a series circuit only. The same current is passing this side and this side. I will get the what now? I can apply the Ohm's law directly. VI by total resistance. What is total resistance? R1 plus R2. Because same current is passing means it is a series only here now. But I want the ratio VI by I. VI by I want. VI by I is nothing but Rn. That equal to how much? R1 plus R2 I can write. Yes, that much amount of input resistance is possible. That way we can get answer now. I think you followed better. Yes, very good Manoj Kumar. R1 plus R2. Very perfectly you give answer. The next question I want to give in your hand. You please try. One question I want to give in your hand. If you are getting answer, very good. Now this question I would like to give in your hand only. If you are getting answer, very good. Otherwise you try as a homework. The question is given like this. Find R in. Find R in for the given circuit. For the given circuit. For the given circuit, I can say. There is an op amp, minus and plus. This is a V0 here. This positive terminal is connected to the ground. Here connected with a resistor and also one more resistor this side. This is R2, this is R1 here. Here connected with V in, VI. And this is the given problem. The direction is given like this. Now find R in this direction. When the view is made this side, you please find it. There is one resistance. This is nothing but RF. That is the given problem. Anybody can give answer for this question without my help? Anybody can give? Anybody? It's a very simple question. Okay, why homework? Now only we can complete. Please tell me. I am expecting your answer. At the beginning you try. Very simple question. What answer is possible in this problem? Any student can give answer? But in this problem, we know very well, V plus is nothing but 0 voltage, grounded, 0 voltage here now. V minus must be same 0 voltage one. If it maintains 0 voltage, it doesn't have any resistance in between these two nodes. At the time, same 0 voltage will be maintained this side also. That means these 2 points we can combine as a single point, we can take it here. Understand now? But now, please tell me, is it going to flow any current across R2 here? Anybody? is it going to pass any current through R2? Yes, it doesn't flow any current across R2. This is a 0 voltage, this is also 0 voltage, difference of the voltage 0, it doesn't flow any current across R2. No current across R2. If I equal to what? No, this current across R1 is a I, same current I will flow this side and can divert to this side. Same current will be diverting. It doesn't have path in this direction because same 0 voltage, no drop across R2, no current is going to flow. And I want to find Rin is nothing but Rin is required Vi by I. Vi by I is required. If once you know the I, you will get the what? No, Rin. What is I? I is nothing but this Vi minus 0 by R1. Vi minus 0 by R1 is possible. I want Vi by I. That is nothing but Rin. That Rin equal to how much? R1 itself. We are getting result is R1 only now. That is the solution of this question only now. Then in that way we can determine Rin value. Yes, I will stop now. In the next class, please try to attend. Tomorrow I am going to do the problems on schema triggering. By using the schema triggering, number of problems we can do them now. Then you can understand. If you attended that class, you can do any sort of any problems in any question you can do. Whether it is asked in the engineering service or GATE or any PSU, no problem. 100% easily you can tackle now. Once if you attended the class tomorrow, understand. Thank you all.